Welcome, my dear student. Today we will discuss the new topic limits. Limits, yes, my students. Let f of x be a real value function, then limit at x equal to a is defined as limit x tends to a f of x equal to f of a. That means left hand limit and right hand limit both are equal. If it is given that the limit exists, then the left hand limit and right hand limit both are equal. Okay, my students? It is the left hand limit and right hand limit both are equal. Then it is for the limit exists. Suppose the function f of x is given 2x minus 1, 3x minus 2, if x less than 1, if x greater than 1. Suppose you have to find the limit at x. Suppose you have to find the limit at x. Then you have to find the limit at x equal to 1. In this point, you have to find the limit. Since you have to find the limit at x equal to 1, so left hand limit x tends to 1 f of x. Instead of f of x, you have to write like this. You have to write these functions. 2x minus 1, you have to write the 2x minus 1. Because x is less than 1. In case of the left hand limit, suppose it is a number line, it is the 1. So x should be less than 1 at the particular point for left hand limit. And right hand limit x greater than 1. It is the right hand limit. Because in case of the left hand limit, x is less than 1. Suppose you have to find the limit at x equal to 1, then x should be less than 1. Less than 1 means 1 से छोटा कोई भी number. 1 से छोटा number means 0 point. Suppose 9999 and this number is, ये जो number है, ये number 1 का एकदम बिल्कुल पास में है, लेकिन 1 से थोड़ा छोटा है, इसलिए आप लेफ्ट लिमिट मान लीजिए a है. That means इसका पास में है. Just x का वैल्यू 1 से थोड़ा छोटा होना चाहिए, पॉइंट डिफरेंस होना चाहिए. But in case of the right limit, x ये जो नंबर होगा x greater than 1, that means 1 0 0 0 0 suppose 1. That means x का वैल्यू उसी पॉइंट से ग्रेटर होना चाहिए. Okay, my students? Next day, now just you submit your limit. Instead of x, you get the result 2 minus 1 equal to 1. In case of the right hand limit x tends to 1. So you have to use for x greater than 1. So you can use this function because you have to find the right hand limit. So you have to use this. That is why you get 3x minus 2. Instead of x, you have to write 1. So you get how much? 3 minus 2 equal to 1. So left limit is 1 and right limit also 1. Both are equal. So limit exists. If you write like this, since left hand limit equal to right hand limit, therefore limit x tends to 1 f of x exists. If both limits are equal, then the limit exists. If the both limits are not equal, the limit is not exist. So my students, I think you understand what I am going to discuss. Just you look here, if a function exists, then the left limit and right limit both are equal. But if it is not exist, then the left limit and right limit are not equal. So my students, I think you understand. Next we can suppose if you want to find the limit at x equal to 2. Suppose you have to find the limit x equal to 2, then x equal to 2 is always greater than 1. X equal to 2 point is always greater than 1. So left limit and right limit both you have to use this one. Because if you find the limit at x equal to 2 and this x equal to 2 is always greater than 1, that means you have to take the left limit and right hand limit, both limit equal to these functions. So in these cases, left limit will be, you have to find the limit at x equal to 2. So you get from us, that is the 2. So left limit and right limit both you have to take this one because 2 is always greater than 1. So 2 का लेफ्ट साइड और राइट साइड दोनों हैं, आप इसी फंक्शन डिफाइन करोगे. Now you just submit your value 3 minus 2, you get almost 6 minus 2 equal 4. Next, in case of the right hand limit also you have to take this one. So just you get so my students, so when I calculate I get equal to 4. Both are equal, therefore limit exists at x equal to 2. Suppose you have to find the limit x equal to 0. In this point, in this cases, x is always less than 1. So left limit and right limit both you have to use this one. Okay, my students, like this. Just you use these functions, left limit and right limit. Both these cases you have to use this one because x equal to 0, this x equal to 0 is always less than 1. That is why you have to use the left limit and right limit. Both the limit is this. So I think you understand what I am going to discuss in these questions. Next, suppose you have to find the limit at x equal to minus 1. Then the left limit and right limit also this one because x is less than 1 and this point always less than 1. Okay, just it is the conception for the first type of the questions. Question number 23, 24, 25 like this. Next type of the questions, it is given in interval. Suppose the next type of questions, it is given in modulus sign. Suppose the modulus sign of x. Modulus of x is given by x if x greater than 0 minus x if x less than 0. So you can use this f of x equal to this mod of x greater than 0 or x less than 0. So my students, I think you understand. In case of the modulus, you have to just, when you break down the modulus sign, then you have to write here positive and negative. If it is greater than 0, you have to write the positive. If it is less than 0, you have to write the negative sign. So suppose any question is given like this, f of x equal to mod of x upon x, and suppose it is 0 if x not equal to 0, if x equal to 0. In these cases, what you have to do? You have to expand this modulus at first. You have to expand this x upon x if x greater than 0 minus x upon x if x less than 0 and 0 if x equal to 0. You understand my dear students? Just according to this, because if it is a positive, x is positive, you have to write the plus sign. If it is negative, you have to write the negative sign. So in these cases, you get, when you cut them 1 minus 1 0. If x less than, greater than 0, if x less than 0, if x equal to 0. So I get this below, this two below I already get. Now, if to suppose if to find the limit at x equal to 0, then in case of the left hand limit x tends to 0, f of x. So limit x tends to 0, In case of the left hand limit, you try to use this because x is less than that's a particular point. So you have to get -1 equal to -1 because there is no x to submit. Right hand limit x tends to 0 f of x. So I get the limit x tends to 0 f of x. F of x means this one 1. So I get 1 because there is no value of x to submit. So I already get this one. But the both are not equal. That means limit is not exist. So my students, I think you understand. If any questions, if it is given limit x tends to 1 f of x, if it is given, then if the left hand limit, right hand limit both are equal at this point x equal to 1. Okay, so I think you understand what I'm going to discuss in these questions. Suppose the modulus also denominator, then you have to do also like this. So like these questions are very important, and up to question number 26, 23 to 26 are already finished if you understand these questions. Okay, my students, thank you.